Welcome to the project demonstration of Smart IoT Energy Meter Monitoring and Controlling System. So in this project we are going to monitor the kilowatt hour readings along with the billing details of this system from the Blink application, and that can be accessed from anywhere in the world directly. And the next we are going to display the so-called same status on this LCD screen. And also whenever you want to control the devices, whether it's crossing threshold value by seeing them, you can just control them with the help of the switches. So these are the readings in kWh, and the switches are used to control the devices. So here the kilowatt hour and the bill in Indian rupees directly. So when we before on the gate, so we can see that the device is offline, means the device was not connected to the internet. So coming to this device section, so we are using three electromagnetic relays to control the three loads, where we are going to connect the 230 volts and up to 1000 watts load can be connected on each slot of this 3-pin socket. So these three relays interface to the PIC16F73 microcontroller at pin number of C0, C2, C3 pins. Sorry, C0, C1, C2 for the three relays, and the LCD interface at the pin number B2 to B7, and Wi-Fi module, which is the main communication device component between the microcontroller and the Blink application. So that is the ESP8266 interfaced at the C6, C7 pin of our microcontroller. And the next another main component is optocoupler. So here we can see this small IC which is of acting between the energy meter and our microcontroller. So on the energy meter, the kilowatt hour measured with help of this last LED. We can see that this last LED will blinks whenever the load connected. So when the load increases, the blinking rate also increases, means the fastness of the blinking rate increases. So that blinking rate is parallelly given as input to this optocoupler. So when we have connected that to this optocoupler, then the LED won't blink as we are getting the output at this optocoupler end. So the main purpose of this IC board, the IC board is used to protect the microcontroller from this energy meter, means whenever the short circuit occurred inside this energy meter, then the microcontroller may get damaged if we provide the input from this LED to the microcontroller directly. So when we place the mediator, this optically coupled IC, that is a PC817, so only the IC will get damaged when the short circuit occurred, so that we can protect the remaining whole circuits. So for that purpose only we are isolating the input from the energy meter to the microcontroller. So that was connected at the pin number A4 of our microcontroller, and this is the regulated power supply board which will take 230 volts AC inputs, and it will provide the 5 volts DC output directly to this microcontroller, as it has the stages of transformation, filtration, rectification and regulation. Transformation will step down the 230 volts AC to 12 volts AC, and rectification will convert the AC to pulsating DC. Filtration will remove the pulses and provide us the constant 12 volts DC output, but we need 5 volts as the operating voltage is 5 volts. For that purpose the 7805 will be placed, and we are getting 5 volts constant DC output. So parallelly we are providing the same 230 volts input to this energy meter, and output is given as input to these three sockets through this electromagnetic relays. So let us see the demonstration. Before on the kit, the very first step we need to do is install the Blink application from the Play Store. So Blink IoT, install that application, and after that log in to that application from the given credentials, and then on the hotspot, go to hotspot settings of your phone, change the hotspot to project 5404 without any space, without any capital letter, and password should be 123456789, and AP band should be 2.4 gigahertz. So after enabling these settings on the hotspot along with data, and then after log into the Blink application, so there we can see the device is offline. So open that, no need to open that, wait till the device is online. Now on the power supply to the kit, just provide the 230 volts AC inputs. So when you on the gate, take care, don't touch on this one, on here. So we are getting 230 volts directly on the circuits. And let me connect the 230 volts to this, better to use high wattage, and you can use the 1000 watts load also. No need to worry about that. Just I'm connecting the soldering iron and the next glue gun, so which has the indication of LED over there. I'm connecting on this. Right now, after you switch on the kit, so you can see the device is online. The offline mark goes away. So after offline mark goes away, then reset this motherboard. This is a reset switch. Just restart the motherboard. If the blink application input was not control the relays, just restart the microcontroller only once. As you can see that the 00 for the bill and all. Open this application. So now on the devices one by one. So device 1 got switched on, device 2 got switched on, and device 3 also got switched on directly. Now check the total 3 devices are on state only. Right. So the device is on. Off the device. Okay. Right. So as of now, the reading is getting increased, and also the bill also getting increased. So in this manner, we can access the total devices from anywhere in the world, and we can get the energy meter reading also. Okay, so while controlling, you just provide the time gap between that. If it won't respond, just reset this motherboard directly. Then after that, the readings will be comes down to 0. Right, and now we can control the devices after some time. Let me check the data connection here. Right, so show the data connection properly. Right, now we can controlling the devices directly. Just give once again duration gap between on and off.